Hi there, I'm KHADER and I like to make electronic projects. So today we're going to talk about Kback. So how this device works is, if you have a device which runs on two AA batteries like a landline phone or a small toy or a LED torch, then you need not every time replace two batteries. You can place this device in one of the battery slots. As you can see, it almost looks like a AA battery. So you can place this in one of the battery slots, and in another slot you will keep a AA battery. So what this device will do is it will convert the voltage of a single battery into the voltage of two batteries. That's around 3.2 volts or 3.3 volts. And not just that, if you have dead batteries which you throw away, at least have 75% of the charge still left in them. That's around 1.3 volts to 1.2 volts. So what this device will do is, this device can operate from 0.6 volts. So it will also utilize that low voltages to convert to a higher voltage like around 3.2 volts. That's the voltage of two batteries. And one of the advantages of this device is all the circuitry used in this device is fixed inside this case, so that this can be easily placed in one of the slots of the AA batteries. So today we are going to see how to construct this device, all the circuitry and the placing in the case, and how this device can be used in a device. So let's see.
The heart of this circuit is a voltage circuit, which is used to convert low voltage from the battery into high voltage peaks. The supply to this circuit is a 1.5 volts AA battery. I used a BC5% transistor to construct the circuit and a base resistor of 150 ohms. An LED can be connected across the collector of the transistor to light it using a single AA battery. But in our application we don't need that. So what we are going to do is, we are going to replace the LED with a high-speed switching diode such as 1N4148 diode and a capacitor to convert the signal to DC signal. Originally, at the collector, the signal is in the form of peaks, whose voltage ranges from 20 to 30 volts. The wire used to construct the toroid is a 24 gauge wire. I used an Ethernet wire. You can also use an enameled copper wire. I wound about 10 turns of two 24 gauge wires around the toroid. To get more current from the circuit, you can reduce the gauge, that is, increase the thickness to about 20 gauge or 22 gauge wires. You can also reduce the base resistor to about 68 ohms or 56 ohms to get a higher output current. The output voltage of this circuit is about 30 volts, which might damage the device which we connect it to. So what we need to do is, we need to connect a 3.3 volt Zener diode across the terminals to limit the voltage to 3.3 volts. Or we can also connect a 3 volt Zener, but as the maximum voltage of two new batteries is about 3.3 volts, we connect a 3.3 volt Zener diode. For the construction of the toroid, I'll use a ferrite core which I salvaged from an old CFL bulb. I'll take an Ethernet cable of about 10 cm length to wind the coil. As it is a twisted pair, I'll open the cable to get two 10 cm pieces. I will straighten the wires first and then start winding through the ferrite core. I'll cut the extra ends and also remove the insulation of the end wires. Now I'll connect the white wire on one side of the toroid to the brown wire on the other side of the toroid, like this. Now let's connect the circuit and see. Now let's connect a battery and check. As you can see, I connected an LED first, so the LED is glowing. That means we are getting enough voltage at the output. Now I'll measure the output voltage, removing the LED. As you can see, the voltage is about 26 volts. Now I'll connect a 3.3 volt Zener diode across the capacitor to limit the voltage. Now I'll connect the battery and check the output voltage. As you can see, it should be 3.3 volts, but it's 3.5 volts. The extra 0.2 volts can be the voltage spikes. Now I'll connect the circuit. You can solder the components together, but I prefer to just connect the terminals by twisting the wires. After connecting all the components, the circuit looks like this. I made this in this shape so that it can easily fit inside a battery casing. I connected a wire to the negative terminal of the circuit and tested it with an LED. As you can see, the LED is glowing and the circuit is working. You can make the enclosure of a Kback using the metal casing over the dry cell batteries.
I covered the whole circuit with some insulating tape so that the terminals don't get shorted while placing inside the battery casing. Now I'll try to place this circuit inside this metal casing which we salvaged earlier. Make sure that the output terminal of the circuit comes out from the positive terminal of the battery and the input through the negative terminal of the battery, so that we can attach the positive terminal salvaged from the circuit onto the top and the negative terminal at the bottom, and the common ground wire comes from the center of the casing. I will attach the positive terminal to the output terminal of the Kback using some solder. Now I'll fix the terminals. But before fixing the terminals, what will I do is I'll fill the inside empty space with some rubber pieces so that the terminals can be hold strong. Now I'll solder the negative terminal of the Kback, which is taken from an old dry cell. Now I'll mix 2-part epoxy and apply to the terminals and the casing, which helps to hold the casing firmly. After the epoxy is dry, I sanded over the surface with some fine sandpaper. You can leave it as it is or paint it with some black color as I did.
Now the device is complete. As you can see, the device dimensions are almost equal to the AA battery dimensions, so it won't be a problem to fit in the AA battery slots. Usually the battery slots are like this. It has pins on one side and the other side. So we'll place the battery like this, such that the positive terminal will be touching this side, and the other battery like this. This is a shorted plate which connects these two batteries in series. So now what we'll do is we'll place the Kback device in this side, such that the positive terminal of Kback touches the positive terminal of the device. This is positive terminal and this is the negative terminal. And this extra wire from the Kback can be connected to the negative terminal of the device like this. It can be simply placed into the spring. Here the negative terminal of the Kback touches the positive terminal of the AA battery which you are going to use. Now we'll test this device on this landline phone. As you can see, initially the display is very pretty dim. You cannot see the ear also properly. The batteries must be pretty dead. Now what I'll do is I'll replace one of the batteries with my Kback device. So we'll take one of the batteries out. As you can see, even after removing one battery, the landline is powered from the phone line. I'll place the Kback device now. The positive terminal of the Kback goes to the positive terminal of the landline phone, and the black wire goes to the negative terminal of the phone. I will connect it. And now you can see that the display is bright. You can see the letters clearly. The display is already damaged at the ends, but you can see the ear clearly. Now I'll remove the wire, and as you can see the display dims slowly, and once again if I place it, the display becomes bright. The Kback device is also compact, so it won't obstruct in closing the cabinet.
So that was my Kback. So while construction of this, make sure that the terminals don't short because the body is metal. And if the both terminals short, then what will happen is the input voltage will become the output voltage and you won't get the boosted voltage, you will get the same voltage. and it's a very simple design, and you can make it in maybe a 1 day or 2 days project. So make this and use it in your devices. In emergency cases, we may not have availability of AA batteries, then we can use the same used batteries to run the device again as good as new. So thank you for watching this video. If you like this video, please give a thumbs up, and I'll be posting videos almost every 1 week or 10 days, and if you like my videos, please subscribe to the channel for my future videos. Thank you.